So they're sitting on these patches whilst they roll out their new system. That's their judgment call. Personally, I think they're putting their customers unnecessarily at risk, because if I've discovered a bug, you've discovered a bug, potentially the same bug. We just have to look to one of the more recent, this month's Microsoft rollup patch. Several people were credited for discovering the same security vulnerability. This happens time and time and time again. Now, most people, well, I hope most people think of me as a good guy, but if there's a bad guy out there who's spending time and researching Oracle security issues or software security issues, whilst I might be a good guy and work with the vendor to get these problems fixed, if he's discovered it too, or she's discovered it too, and they're going around popping systems, then Oracle's customers or vendor X's customers are being popped, actively popped, whilst they're sat on patches. Now, to me, I would say, you know what, your old system worked because people got patches, so keep that system rolling whilst whilst you roll out your new system, and at midnight on a given date, once you know the new system is working, switch over, and then start your new patching process. Do not sit on patches. If you have them ready and they're robust, give them to your customers. That's my point of view. So, I'm sorry, that's a very long-winded answer to your initial question. Is it reasonable? In some of the bugs, yes, it's extremely reasonable because of the amount of operating systems they have to support, and it requires major re-architectural changes. Some of them, no. It should have been fixed within a week. Chris Anley from NGS Software, one of my colleagues, discovered a bug in MySQL, one of the development versions. Now, essentially, what the problem was, we could pretend to be an older version of the client connecting to MySQL, but when we get through that stage, we then say, well, my password length hash kind of thing is null, and it would return 0, and we would be authenticated without actually having to present a password. And this was like, Chris discovered this about 4 or 5 weeks ago. He sent the mail to MySQL. Within 24 hours, they had patched it. Within 10 days, they had released updated binaries. So we're dealing with 2 RDBMSs here, both that operate on multiple systems. Now, MySQL can do it in 10 days, distribute binaries, whereas other vendors take months. Sure?
Can you tell us what the nature of the vulnerabilities are, even though you can't tell us what they are, just so we can get kind of an idea of how...
Well, if I said to you, there's a bug in Linux, I would feel safe in telling you that. Okay. So, in terms of what we're dealing with, there are remote, unauthenticated overflows that allow us, as a user without user IDs and passwords, to gain control of the system. There are PL/SQL insertion bugs, which is going to be form the larger part of my talk today, actually. There are buffer overflows that require authentication. And this is in 10G, 9i, 8i, all the way back to 7, even though 7 is not supported anymore. The point is it's still there. What else is there? Trigger abuse. I haven't actually seen publicly posted yet, and if anyone knows in this room that I'm wrong, please correct me and tell me about it. And I'm really interested to know, actually. Triggers. We'll cover this further in the talk in a minute. But triggers in all RDBMSs run with the privileges of the definer. So essentially, if the DDO, the database administrator, the DBA, owns a particular table and he wants to ensure that when someone updates or deletes from that, they're going to set a trigger on to make sure that the data is the right kind of stuff. Well, if it's not the right kind of stuff, that trigger needs to be able to take actions that can, manipulate data in that table, potentially. So it needs to run with higher privileges. Now, triggers are vulnerable to SQL injection. There are several examples in a default install of an Oracle RDBMS. It's the only RDBMS I've actually found them in so far. However, I don't think it's an Oracle problem, especially if you're coding your own, triggers. You've got to be thinking about this. Am I going to be exposed by someone updating a table, whether it be through a stored procedure or not? Am I going to be owned by my database triggers? So it's an area which really should be looked at in greater depth. So let's start with the talk. So the talk is about PL/SQL security considerations. So what is PL/SQL? Well, it's easy to say what it stands for, which is Procedural Language Structured Query Language. No, it's not easy, obviously. Stands for Procedural Language Structured Query Language. And it's basically Oracle's extension to the standard SQL stuff. For those who are more used to the Microsoft SQL Server world, it's very similar to TSQL. PL/SQL can be used to create stored procedures, functions, objects, triggers, anything which requires real functionality. You do it with PL/SQL. You can do it with Java, but by default, it all runs off mostly PL/SQL. So if you're actually going to be looking at the security of an Oracle RDBMS, if you don't have a handle on PL/SQL, you don't have a handle on the RDBMS itself. PL/SQL can be extended using external procedures. Now, traditionally in the past, that's been a real soft spot for Oracle. We'll go over this in further detail shortly. But external procedures, actually I'll get to that in a minute. Okay, so we have this bit of code written in PL/SQL. How does that execute? When we execute that bit of code, with whose privileges does that bit of code execute with? Well, by default, it executes with the privileges of the definer, the guy or girl who writes the actual bit of code. So if sys, i.e. the most powerful account on the RDBMS, creates a stored procedure and it's vulnerable to SQL injection, when that is exploited, the injected code will run with sys privileges. So we can own the database server. There is invoker rights, whereby we can specify an authID keyword, current user keyword, essentially, that says, you know what, if Joe Bloggs runs this procedure, run it as him and not as me, the definer. Which is a much more safer way to go if you are allowing access to, if the stored procedure requires access to a specific table, then you must give that user specific access to the table. Otherwise, their privileges, won't carry through and the procedure screws up. That's, of course, if you want to allow that. So, in terms of the default situation, PL/SQL code will execute with the rights of the definer. Somewhat similar, for those Unix guys out there, to SUID programs. When the S-bit's set, it runs as root, essentially, once we do the call the relevant functions and so on. PL/SQL can be called over the web. Most Oracle, well, when I say most, I'll probably guess about half of the Oracle web applications out there, are actually written in PL/SQL. Now, one common mistake that people make is thinking that the PL/SQL code is executing on the web front end. It's not. The Oracle application server is connecting to the back-end RDBMS, and the code executes on the back-end system. So, if it's vulnerable to SQL injection, or there are functions which are vulnerable to buffer overflows or format strings or heap overflows, whatever, then it's occurring on your back-end system, i.e. we're in your network, you know? PLSQL functions, procedures, etc. can be encrypted to hide the details, the business logic, from prying eyes. Now, the Oracle term for that is called a wrapped procedure. Oh, bugger. Sorry. A wrapped procedure is essentially encrypted text, which is reversible. Too many people think, and I've seen some of the Oracle experts say, you can't reverse it. Well, you can. It must reverse it to actually execute the thing, you know, to actually execute the procedures on a package, you know? Rather than disassembling the way Oracle, in their cookbook fashion of encrypting this stuff, you just need to set a couple of breakpoints in a debugger and capture the clear text. It can be done very, very, very easily. External procedures we touched upon briefly near the beginning of the talk. So let me explain what an external procedure is. Oracle provide tons and tons of functionality within the RDBMS itself by default. It's great for that. The downside is, of course, the more functionality there is, the more likely it is to be popped at some stage or other. However, as far as functionality goes, they have done an outstanding job. You cannot fault them there. To extend the RDBMS further, Oracle have a facility whereby you can connect out of the RDBMS itself and load a library, a shared object, and execute a function and pass it parameters of your choosing. Basically a C function, essentially. Now, the way in which that occurs is by the Oracle process itself connected to the TNS listener. So before I move on with this, actually, let's explain a bit about Oracle architecture. On a Windows system running Oracle, we have the main Oracle process. That sits there waiting for connections from clients, essentially, and to serve requests. But the client has to go through the TNS listener first. The TNS listener is the thing that listens on 1521 or 1526, depending upon, you know, what kind of version of Oracle you've got installed. So when a client connects to 1521 to the TNS listener, the TNS listener then sends a message back to the client saying, you know what, don't connect to me on 1521, but if you connect to port 4001, you can actually get access to real Oracle database services. So that's what the client does, it connects. So the TNS listener listens for client connection requests. Now, as far as the external procedure stuff is concerned, the Oracle process connects to the TNS listener and says, I want to load this library, execute this function, and pass it these parameters. Well, the TNS listener says, well, I'm lazy. You know what? I'll launch xproc, and it will do it for you. Connect to it on port 5002. So that's what Oracle does. It connects to the xproc process, and Bob's your uncle. Oracle says to xproc, you know, hey, load this library for me, execute this function, and pass it these parameters, and xproc willy-nilly does that. None of this, because it's process to process, is authenticated. None of it is authenticated. So, you know what? I, as a remote attacker, sit on the network over there and speak to an RDBMS over there and say, I'm the Oracle process. Please load this library for me and execute this function. Well, the TNS listener says, oh, this Oracle speaking to me. It must be. Who else would do that? You know? So it launches xproc, and then it says connect back to xproc on such and such a port. So sure, fine, I'm going to do that. You know? Bang, we're in. Xproc launches loads the library and executes the function. So you know what? We can call system. We can call any function exported by any DLL on the system, which is pretty bad considering this is all unauthenticated. So Oracle actually patched this to a certain degree. This is all public knowledge at the moment, by the way. It's been published in various places. So the patch essentially says if it's coming from a remote system, do not allow it. But if it's local, you know what, it must be Oracle still, so allow it. So people who are local to the system can still do this. Remote users, however, well, Oracle have started logging remote connection attempts to launch libraries. And they call sprintf without doing any length checking on the length of the library name. So there's a classic stack-based buffer overflow there. Again, same bit of functionality, they get popped, you know, but with a classic stack-based overflow. There are other improvements were made, for example, actually. The DLL now must exist in the Oracle bin directory, you know, the Oracle home bin directory. How to say this? Moving on swiftly, there are more issues in this area. So we're going to look at a wee bit of PL SQL injection. Select statements. If we have a stored procedure that does a select, the standard, you know, almost like the hello world of SQL injection, you know. We're going to cover those. DML, data manipulation, basically. Procedures that do updates, deletes, inserts. We actually can do more through SQL injection with a procedure that calls something like a delete, update, or insert. The best of all, as far as an attacker is concerned, is being able to inject into an anonymous PL SQL blocks in procedures. Now, let me explain what an anonymous PL SQL block essentially is. So if I'm sat there in SQL+, you know, the standard client to connect to the Oracle RDBMS, and I say begin, you know, execute immediate, do this, end, semicolon, slash, bang. It's an anonymous PLSQL block. It's almost like a batch query in the SQL Server world, but because it's not confined to an actual procedure, it's just, I'm sat there coding it, it's anonymous, right? There are actually procedures in packages, PL SQL packages, that embed anonymous PL SQL blocks into the procedure. Now, with that, basically, we have batching. And with batching, we can do terrible things to the system. So let's look at a simple PL SQL select example. Here we go. Can you guys read this at the back? Or would you like me to read it to you? No? Okay, essentially what this is doing, the procedure is called list libraries. It takes as a parameter the name of a user, an Oracle user, and essentially all it does is list the libraries owned by that given user. You know, whoop-de-doo, what, you know. Is that visible at the back? Do you want me to change the color? Okay. So, exec sys.list libraries, bracket, single quote, sys, single quote, bracket, semicolon. That's what I'm executing here. And I get a list of libraries back. If I enter two quotes, I get SQL command not properly ended. And that's essentially because, going back to the actual procedure itself, what's happening is, I'll do it over this side too in a minute. Where are we? P-owner, here. This is the parameter we're passing it in. With the double pipe, we're actually inserting it into a cursor without actually validating the input. When that cursor is executed, when data is fetched from that cursor, basically our arbitrary SQL can be inserted. So I'll just show you guys over this one. Here's the crucial point here. P-owner with the double pipes. It's just being plonked straight into the query. Select object, whatever that says, from that table. So in terms of exploiting that, it's really quite easy. Let's actually do this. Right. Excuse me. Union select. Password. From DBA, actually let's put sys in front of that, sys.dba underscore users, single quote. Oh yeah. Yeah. Minus. So there we go. As the user Scott, we have just dumped the list of password hashes from DBA users, a view which maps to user dollar, and we have a list of all the password hashes, and which we can do whatever we want with. But hey, we're getting information back to the screen. This is easy. What about if we don't get any information, printed back to the screen? Slightly more difficult. So let's look at an example of that. So we have a function here, owned by sys, that basically does a select count from a given table based upon user input, and the count function essentially says how many rows match this criteria and return that number. Can you guys see this? Yeah. The important part here is the statement equals select count bracket star bracket from all objects where owner equals user input, just in here. And then it's executed immediately with the execute immediate. Now, the traditional way, with a union select kind of attack, or exploiting these kind of issues is not going to work. Nothing is being printed back to the screen. How are we going to get data out? For example, if I tried the standard union select, I would get an error. 1790. Expression must have same data type as corresponding expression. It's not going to work as normal. If I try and even get numerical data back, use a hash, which is numerical data in sys.user$. We get exact fetch returns more than the requested number of rows. So that's no good either. If we try and do a subselect, it just returns 0. It's like, Jesus. Oh, sorry, I shouldn't say that. No, joking aside, I really shouldn't say that. So how do we exploit this then? Well, if we can define our own functions or procedures, which by default the standard group permissions allow us to do, for example, Scott is a member of Connect and Resource. Connect and Resource basically allow us to create procedures. If we can create procedures, we can create functions, we can create objects, anything that requires PL/SQL coding. So what we do is, providing we can create our own procedures or functions, we do that. So here we create our function getIt that basically does a select password from sys users where name equals sys. That's the only thing we're really interested in. And then we select that. So, let me actually just cut and paste that. So, I'm going to, that's sys, right, that's Scott. So, Scott's just created this function. He then needs to grant execute on, what do we call it, getIt, to public. So that way, when it's called, everyone can run it. Now here's the trick here. Because we're going to be injecting into something which has been defined by sys, and it executes as sys, if we inject a function, because we're defining our own function, if we inject that, because of the default rules, when the sys procedure or function executes our function, it executes as us, because, we're the defining. So what we do as an attacker is basically specify the auth ID current user. So when the sys procedure, when we execute the sys procedure, and we inject our function, when the procedure actually executes our function, and we've specified the auth ID current user keyword, it runs as sys. So it doesn't run as Scott. So if I select count, Scott dot getIt. From dual. Oops. Missing right parentheses. Sorry. One, two. Tell you what, here's one I prepared earlier. Right, where's our data? It's like we asked the getIt function, going back, to spit out the sys password. If we now go exec dbms output dot put line hello, there we go. There's some kind of buffering issue going on here, but the point is, here is the sys password hash, which is obviously crackable. Incidentally, the rest of the getIt procedure also lists other DBAs in the system. So we can see that sys is a DBA, WK sys is a DBA, CTX sys is a DBA, system, and yeah, that's it. So there's a bunch of accounts there someone would, go after. The limitations with injecting into select statements, whether you inject your own function or not, we cannot perform DML operations, data manipulation stuff, such as insert, update, delete, and so on, or DDL data definition language stuff. If we have a procedure which actually performs an insert, an update, or delete, we can actually piggyback DML operations on top of that. So if I can inject into an update procedure, I can perform a delete or an insert, and so on, and so on, and so on. We're not limited. And we can also perform selects as well. So here's a DML example. We are running out of time, so I'm actually going to try and skim through these quickly. The point is, there is an insert operation going on here which is immediately executed. The vulnerable point being here, taking the user input without validating it, and stuffing it into the query, which is then executed. We can piggyback various nefarious, I'm a poet and I didn't know it, various nefarious different SQL DML statements. So, again, we can inject a procedure, or a function rather. For example, we could actually update the password for the sys user, change it, essentially, providing, of course, the stored procedure is owned by sys or a sys DBA. The problem is, whilst we can do more when we inject into DML procedures, we can't do DDL stuff, which essentially is the grant DBA to public, make everybody own the system, which is the domain of injecting into anonymous PLSQL blocks. Fully flexible. If it's SQL, it can go in, providing, of course, the permissions are there. So assuming that sys has vulnerable procedures which actually inject into anonymous PLSQL. And by exploiting these, even the lowest privileged user on the system can become a DBA. Here's an example. Our statement is basically begin DBMS output, put line, user input, end. Something naff. It doesn't actually do anything much. But we execute that anonymous PLSQL block. If we, in here, insert a semicolon, grant DBA to public, public is now a DBA. Sure?
I'm sorry. I think I'm missing something. Where does the unbreakable part come in?
So, moving on. Be careful with triggers. I spoke about triggers earlier on. They can be abused to own the system. If you are responsible for coding triggers on an Oracle RDBMS, ensure that the :new or :old, or alternatively :n dot field name, :o dot field name, is not being dumped into a SQL statement which at some point is executed, unless you are validating the data before you execute the statement. There are a number of triggers which are vulnerable by default on an Oracle RDBMS, which are vulnerable to this kind of abuse. The key, the most important thing that one can do to protect themselves against PL SQL injection is to use bind variables. Now, what a bind variable essentially does is say, you know what? There's the query, compile that into a query tree. Once you've done that, dump the data in thereafter. So whatever's in the data, no matter what nefarious content you put in there, because the query tree has already been compiled, you ain't going to do diddly squat, That said, you have to think about second-order SQL injection kind of issues, because people are expecting perhaps nasty data coming from a client. But if data is coming from the database server itself, well, hey, that's more trusted, right? Well, no, because I update the database server with my nasty little bit of SQL, and if you're not using bind variables, if you're not validating input, because it's coming from the database server and therefore is, supposedly somewhat more trusted, which it's not, then we can get you with second order SQL injection. And in actual fact, there's probably going to be things like tertiary SQL injection and so on, all the way down the line, especially when you're dealing with linked servers and so on. Validate input. There's another key point. Sorry, I almost missed that. If you're expecting a certain kind of data, ensure that's what you're getting. Very simple to do. Takes a wee bit of extra time to actually validate the stuff, but it's going to save you money in the long run, you developers out there. Or save the organization you work for. Anyway. So, thank you everybody for coming. I'm sorry it had only half the content I intended it to have. Are there any questions? Yes, sir? I'm going to give them, yes, actually, for those who are interested in these slides, I'm going to give them to Jeff, and he'll get them on the Black Hat website. So if anyone wants to download them, you'll be able to get them shortly.